analyze this. Can I select? Hi everyone, today I'm going to talk about center of mass. So what is center of mass? Say it like that. It's basically the point where you can concentrate all of the mass. Don't do that. The center of mass is the point where you can apply all the force and it will behave as if it's acting on the whole body. For example, that. See, that's like a paper, a really long paper, but it's a paper, okay? And I take a point over here, like that. If I apply force on this, say if I lift it up or I push it down, the whole paper is going to move. Try it out. You can find the center of mass. So the whole paper is going to move up, or the whole paper will move down or sideways or left or right, or however you do it. But if I apply a force over here, then that's going to be different. It will slide off. Like if I use a pen, the pen will slide off and the paper will fall down. So that's not the center of mass. If I take, for example, a circle and I apply force on the center, that's the center of mass. So here, this is the center of mass. This point is the center of mass. Here, this is not the center of mass. If I apply force here, this is not the center of mass because it doesn't identify with that behavior of things being concentrated on one point. So like for example, if I want to define it, I can say, put in quotes to make it fancy, the center of mass is defined as, according to NCERT, it's defined as the point where all the mass of that body can be concentrated. I write really slow, don't I? So that's definition wise. If you want to mark it up, don't mark it up. But that's the definition of center of mass. I want to find the center of mass of, say, a system of particles, of a bunch of particles. Say I have two particles, A and B over here, A and B, and say A is at a distance x1 and has a mass m1. B has a mass m2 and is at a distance from the origin place, at a distance x2. Now again, when you measure center of mass, it's going to be with reference to some point, right? If I take it over here, the center of mass is going to have a different value. This distance is going to be my center of mass. If I take it from the origin, this distance is going to be my center of mass. So again, right, when I use the center of mass, it's going to be with reference to some value, some point rather. Now, usually we take it with respect to the origin. So I'm going to show you how to do it from the origin. I want to find the center of mass of this system over here. If I say M1 was equal to M2, then that's not that much of a problem, is it? It's just going to be the average of these two distances. It's going to be over here. Again, it's x1 plus x2 by 2. That's going to be my center of mass if M1 is equal to M2. But if M1 was not equal to M2, M1 was not equal to M2, say maybe M2 was greater than M1, then just think for a bit, where do you think the center of mass would be? Will it be towards A or will it be towards B? Now, experiments, and if you think that tuition, well, it's going to be towards B because B has the greater mass. I can give you an example. If you maybe make a rectangle, I want to say a triangle, like cut out a triangle out of paper if you're that jobless, but do it. And if you try pushing it up from the center over here, it's not going to get pushed up. It'll slide off this way. You know why? Because that's not the center of mass. The center of mass is going to be towards the heavier part, towards the part which has more mass. Because if I divided this part has more mass than this part because it has more volume, and density is mass by volume. Mass is density into volume. So the center of mass is going to be towards here, maybe probably somewhere here or something. Try it out. So if I want to find the center of mass for this system, if m2 was greater than m1, well, now like I showed you, it's not dependent only on the distance, it's dependent on the mass as well. So if I just think of something like m1 x1 plus m2 x2 by m1 plus m2. Oh wow, it's right, because that's what it is. I can't prove this to you because I don't know how, but just mark this up, and I can tell you an easy way to remember it. But for this system, this is the center of mass. If I take maybe another system, like this probably seems really hard to mark up, but I'll show you an easier way just by proving you another case. Okay, I'm not proving you, but I'm just going to be giving you something. If I take this as A, this as B, this as C, maybe A had x1, B had x2, and C had x3, but this is going to be minus x3 because it's to the left, and displacement matters because it's the center of mass. It's going to be different because, like I said, if I took a point here, it's going to be here. If I took a point here, it's going to be different. So the displacement of the particle matters. Now if I want to find the center of mass of this system, what do you think is going to be? I'm going to say this is m1, m2, m3. Excuse the handwriting, I don't have an Apple pencil, I'm not rich. But the center of mass is going to be m1 x1 plus m2 x2 plus m3 into minus x3, because displacement, boys and girls, I'm not sexist, by m1 plus m2 plus m3. Well, that's going to be my center of mass for this system. Can you understand this? Okay, it's m1 x1 plus m2 x2 plus m3 into minus x3 divided by m1 plus m2 plus m3. Could you understand that? I hope you could. So that's the center of mass. Now I want to generalize it. If I want to generalize this, can I select? Can I select? Can I select? Oh no, you need the pro version. No, that's not fair. But if I want to generalize it, as you saw from this case, this was this and that was that. This and this. You can kind of draw an inference, and I can say, as you can see, this is the mass into displacement, mass into displacement, mass into displacement. Here also, it's mass into displacement, mass into displacement. So if I want to generalize it, I can say the center of mass is the summation of the mass times displacement of every particle divided by mass plus mass plus mass, mass plus mass. So divided by the summation of the mass. And let's say if I had 3 particles, it would be mixi. So I have to do this I thing because sigma rules. So I is gonna run from 1 to n depending on your number of particles. So if I have 3 particles, that's gonna be 3. So you're gonna have 1, 2, 3, 1, 2, 3. If I have 4, it's gonna be 1, 2, 3, 4, 1, 2, 3, 4. So that's gonna be our thing. And this is a general formula for center of mass. So what's it gonna be? The summation of the mass times displacement of every particle divided by the summation of the mass. That's your center of mass, or a limited number of particles, or a given number of particles rather. Thank you.
Hi everyone, my name is Anirudh, and what you saw now was a short clip of something I've been trying on, a project I've been working on. And if you want me to teach any particular topic or another chapter, please let me know. If you think I was going too fast or too slow and you want me to change my pace, please let me know. Also, if you liked, then please like it, or you can subscribe. Thank you.